Hello everyone, welcome to this video. In this video, we are going to discuss about a problem which is called killing spree. Uh, so it's a problem where there are two approaches. One is brute force and one is optimized. So we are gonna discuss both. So the problem states that there are infinite people standing in a row, indexed from 1. A person having index I has strength of I cross I. You have strength P. You need to tell what is the maximum number of people you can kill with your strength P. You can kill a person with strength X if P is greater than or equal to X, and after killing him, your strength decreases by X. Okay, so let's understand the first example. Okay, so N is equal to 14 and output is equal to 3. So what is this basically? N is equal to 14 and output is equal to 3, right? So n is equal to 14 means that we have 14 units of energy and we need to see how many people we can uh, we can kill. That is the question. Maximum number of people we can kill, right? S- And there it's also given that there are infinite people standing in a row. So one, two people, three, four. This just to infinity. Okay, and the energy array is square of the index. So 1, 4, 9, 16, and so on. Okay. So we have been given an energy P, which is long n, and we want to say that how many people we can kill. So suppose we have energy 4. So if we start from 1, first element, if we kill the first element, then we have the left energy left is equal to 14 minus 1, which is 13. Then after 4, it is 13 minus 4, which is 9. And after 9, the energy becomes 9 minus 9 is equal to 0. So how many people we can kill now? We can kill 3 people. So like this the problem goes. So one approach we have discussed that we can go linearly in this way, and we can just subtract n by the current I, n minus I cross I. So we will be getting that. That will take around O n complexity in the worst case. All right. So in this way we will go. We have 14, 14 minus 1 minus 4 minus 9, n becomes 0. In that case, we will print how many it will. In that case, we will be taking answer is equal to I. So we'll print the answer. This is a simple way on linear equation. But can we optimize this? So for optimizing the solution, so we can apply, we have to think a bit, right? For that, we can see the constants. So T here means test cases. So that does not matter a lot. Uh, we can see n belongs from 1 to 10 to the power 12. N belongs to 10 to the power 12 and starts from 1, right? So what is n? The amount of energy. Okay. So 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 we have the energy like 1, 4, 9, 16. So it's always sorted, right? So one thing comes into our mind that if the array is sorted, then we can think of we can think of binary search, right? So if we apply binary search, we can decrease it to log n. So we can think in that direction. Okay. So how we are going to do this? Uh, Here it's given that the energy is like this and to infinity, right? But here, if we apply binary search, what we can do is if we take low here and if we take high here, then we can do, but high cannot be taken as infinity, right? So infinite, it's given. It's not like the integer, maximum value of integer, infinity it's given. So we cannot take high as in infinity. Then apply binary search. What should be the high? That is the main point we have to think about. So here it's given n is from 1 to 10 to the power 12, right? It means that 1 and 1, 4. Let's write the energy array. So it's like this. So at some point, so suppose we take 1, then we take 4. 1, what is the energy? 1 plus 4 plus 9 plus 16. So we'll keep on going forward, and at some point our energy will become 0 or negative, right? So sometime it will become greater than equal to n at some point, right? So for that, okay, so at what point it will be greater than equal to n? In that case, we have to stop. So at what point basically it will become greater than equal to x? So let's take that point as y. All right. And in mathematics, we know this formula 1 square plus 2 square plus 3 square. The formula is to the power n. The sum is n, n plus 1, uh, 2n plus 1 by 6. It's a formula, right? So when we think about this, we can find y with the help of this formula. Let's see how. So the sum of this will be y, y plus 1, 2y plus 1 by 6 greater than equal to n. At this point, we'll break. So n can be a very huge number, right? So 10 to the power 12, it's given, it can go. So compared to that, y plus 1, we can replace it as y only, right? Similarly, to y plus 1, we can replace as y. And if it is greater than equal to n, at that case, we can omit 6 also. So approximately, so it will be, so if we what is our goal? Why are we doing this? We are doing this because we have the value of yeah, so we are trying to apply binary search here, right? So we have taken low as 1, but high cannot, we cannot take high as infinity. So we have to take high somewhere, some finite number we have to take it. So that is the thing we are finding why actually high value high for binary search. So that is the point why where the maximum it can go, right? We can take help of n and we can find that. So for maximum, in the worst case, we can go like n is equal to 10 to the power 12, right? So y will become 10 to the power 4. Okay. So we can take y to this high value to this, or what we can do, right? For we can increase for for being safe, we can increase to 10 to the power 5, because 10 to the power 4, because we are decreasing something like plus 1, 2y plus 1. So y we are decreasing 2 here and plus 1 also. So that is why we can, just for being safe, we can take to 10 to the power 5. So we have got 1, 4, 9, 16. We have got low as 1 and high we can take as 10 to the power 5. Now we can perform binary search. How we are going to perform binary search here, that we will that we'll see. That should be pretty much simple because uh, now we have 1, 4, 9, 16. So here we have got y is equal to 10 to the power 5. So y is what? 1, 2 square, 3 square. The energy value was like this, y square. So y was like an index. Okay, right. So uh, now to perform binary search, we have this energy array now. And now we have to now we have to find uh, how many people we can kill. At what point 1 plus 2 square plus 3 square this becomes greater than equal to n, right? So at what point energy may increase or decrease? I mean, an energy value will become zero or negative. So for that we can perform binary search. How? First, uh, like 1 square, 2 square, 3 square, 4 square, till y value is supposed into power 4. Suppose y, that's y square. So we'll take the middle element, we'll take low here, we'll take high here somewhat. We'll compare a middle square. Like if this is mid, uh if the value, the sum, this sum 1 square plus 2 square plus 3 square plus till mid square, if it is greater than equal to n, if the sum here, if it is greater than equal to energy, the energy which we have, then what we have to do is we have we cannot take these many elements. Then we'll have to decrease certain elements then, as it is already greater than equal to the energy what we have. So if this is the case, then we will have to do high is equal to mid minus 1. Okay. Otherwise, if sum is no, here don't take equal. We don't have to take equal to, because if we, even if it is equal to, we can take that element into consideration. We cannot omit that. We cannot. We don't have to do. So equal to will come here, right? So sum is less than equal to n. Okay. If it is the case, then we will take low is equal to mid plus 1, because we can still go to the right. So suppose we, these many elements are there, and the sum is, after decreasing the sum, this sum from n, we still have some positive value of energy left. Then we can further decrease it, the energy, because we want to know the maximum number of people. So we can further decrease the energy by going to the right. And how we will going to go to the right? By increasing the value of low is equal to mid plus 1, right? So this is the basic thing which we have to take care of. So this was it. Let's try to code and see how it goes on. Right. So we are given with L. We are performing binary search. So we will take some low value as 1, high value as uh, integer it is. So we can do math dot pow 10 to the power 5 we have to take, right? This we have to, and we have taken a variable answer as random answer variable we have taken, right? So we have to perform binary search. For that we do low less than equal to high. Uh, Remember here we are taking equal to, which is important, because whenever low and high become equal, then the mid value becomes equal to the low and high value. That may be the answer, right? If we remove the equal to, then if then uh, even if the uh, we may miss low or high, which may be the answer. So suppose low can be the answer or high can be the answer. We may miss that, right? We will calculate mid value by doing this by this formula. We will have this function. We'll pass mid, and we will check if it is greater than n. Okay. Okay. So what is this function? This function is nothing. It is so we have mid, so we have to calculate this value, right? 1 square plus 2 square plus 3 square, and we had this formula or this one. So this we have to this formula we have to write. Mm, so this formula may return a long value because it may be huge. So plus uh, uh, we are transferring long mid here, not int mid. Okay, let's type this formula here. It is mid into mid plus 1 into 2 into mid plus 1 whole divided by 6. Okay, so if the sum like we discussed here, if the mid sum till mid here it was, if it is greater than n, it means that we are completely devoid of energy. Now we cannot make include more numbers, and then we have to decrease the number. Then we will do we'll have to go left. Otherwise, what we will do, if it is low, then we can take the answer by having L is equal to mid plus 1. Plus, this may also be the answer. If it is equal to, then this may be the answer. So we will, first for being safe, we will have this mid as the answer. This will basically represent the number of people, which will be, uh, you know, the mid value. Okay. So when we come out of the while loop, we will print answer variable, right? So this should run. Function mid greater than n, I mid minus 1. All right. So we are taking answer is equal to mid here. This pretty much is very important because for being safe, we have to take answer because this condition sometimes may be the answer, and uh, you know, so that is why we are taking. So the problem is successfully solved. If you like this video, please, if you find this video informative, please like this video and subscribe to this channel. And I'll see you in the next video. Thank you.